In this session, we'll look at some EDA editing. We start off by first selecting the data format and the analysis type, EDA in this case. We have already selected the study folder, and before going into the analysis, let's briefly review the options. For this analysis, check if the channel is named correctly, otherwise you'll get an error message. We will want to display parameter distribution. I'll explain this later. Check if your signal is calibrated or if you have to multiply a certain factor. And if you've previously done an analysis and you want to look at that, you would click this button. Alright, so everything looks fine here. Let's dive into the data. We will cover the non-specific skin conductance fluctuations right now, which means that we're not scoring responses to specific stimuli, but we're calculating skin conductance level and accounting non-specific fluctuations over certain periods in the experiment. One useful feature often is to display segments which represent the time scale of the experiment overlaid over the signal, such as here, for example. These time segments indicate certain phases of the experiment, and what follows is that some periods of the signal don't need to be edited manually. So I've selected these data, which are particularly bad and noisy, to illustrate the editing process, but usually signals would look much better than this. Okay, let's look at some of those problems here. Hit the rectangle zoom feature and zoom into certain aspects of the data. So here you'll see artifacts on the signal. So these are steep spikes. The signal jumps up and down. This is not a typical waveform for this channel, which usually moves slowly and is usually characterized by slow upward deflections such as these. Okay, so we're anticipating a few problems here. After inspecting the signal, we hit resume. What ANSLAB will do is to detect non-specific skin conductance fluctuations, which we will only see if we zoom into the data sufficiently, and a non-specific fluctuation is characterized by a turn point followed by a rise of at least 0.02 microsiemens within a certain time window before the next fluctuation is detected. So these look fine, but these spikes obviously attracted a lot of non-specific fluctuations, and these need to be edited out here. What you see on the right side is the so-called parameter distribution, which plots non-specific fluctuations by half recovery time, the time from the onset until half of the amplitude was reduced, by rise time, time until the maximum has been reached. Similarly, this plot plots those fluctuations by amplitude and rise time. So what this plot does, it shows fluctuations that are atypical in this distribution, and you can click on those and jump to those fluctuations. So here, since there are so many artifacts, the outliers are actually the correct fluctuations. So these plots are not of much help. We rather have to start editing here. Okay. So clicking to the right of the plot will zoom to the right, clicking to the left of the plot will zoom to the left, clicking above will zoom out, and clicking below will zoom into the data. So for example, this here is a valid fluctuation, but it's overlaid by several spikes and peaks. So we'll need the editing box here to get rid of these problems. So one way to do this is to hit delete, and you can of course delete one fluctuation at a time, which is too much work here. You can also use a delete box, and all the fluctuations within that box will be deleted. Another nice feature is the connect button, which basically means that every part of the signal that is above or below this box will be excluded and the remaining signal interpolated. Okay. Another nice function here is the smoothing window. High smoothing, for example, means that within that box the signal will be smoothed, which is of relevance to the skin conductance level that is also calculated independent of the fluctuations. So smoothing can be used with respect to skin conductance level, but still those fluctuations need to be removed. Let's do a bit more smoothing here. And this looks fine. Okay, so obviously this fluctuation started around here. Another reasonable point would be about here. So we can insert fluctuations. And then this is probably just one fluctuation, so we should delete those and smooth the signal. Good. Another maybe quicker way to look at outliers or artifacts in the whole data set is to switch between raw and event mode by hitting this button. Raw mode is active right now, displaying the raw values, and event mode displays the reduced data that are computed from the raw signals: interfluctuation interval, non-specific fluctuation amplitude, half recovery time, and rise time. By looking at the resultant data in a total interval view, will highlight the outliers across the whole file. We could then target a few of them and just check them by zooming into this part of the data and switching back to raw, like here, where there's a huge jump, which will then result in these peaky amplitude measures.